I'd like to review how to name acids. Let's go ahead and review the rules. There's just three simple things you've got to remember. First thing is hydrogen is always first. So hydrogen is the first element. After that, it becomes a series of questions. Is oxygen in the acid? And we've got, excuse me, we've got two possible answers. We've got oh no, and oh yes. If it's oh no, then the name equals hydro blank ic acid. And we'll talk about what goes in the blank in a minute. If it's oh yes, we're going to look for two endings. With the 8 ending, the name equals blank ic acid. With an ite ending, if your anion ends in ite, then the name equals blank us, O-U-S, acid. So really three things. No oxygen, hydroblankic. Oxygen, 8 is going to be blankic acid, and ite is going to be blankus acid. Now the blank, that blank that is equal to the anion root which is simply the anion name without the either INE, IDE, ATE, or ITE ending. The exception here or exceptions are phosphorus and sulfur. Exceptions. So phosphorus containing acids that root is equal to phosphor and the other exception is sulfur. So sulfur containing acids, that root is the full word sulfur. And we'll take a look at a couple of examples on how this works. So some examples here. Let's take something like HBr. So it's got hydrogen in front, so it's an acid. What I'm going to do is I'm going to take a look for oxygen. Is oxygen present? Do we have any oxygen? The answer is no. So the name becomes hydro blankic, well, that root goes in here. This is the bromide ion. So what we do is we remove the IDE. So it becomes hydrobromic acid. Let's try another one. HCN. So again, I ask myself, is there oxygen present? The answer is no. So this is going to become hydro blankic. Again, I want to identify that anion. There's my anion. It's the cyanide ion. So again, I'm going to drop that IDE. You know what, I should probably put that in lowercase. So I put CYAN in there, cyanic acid. Let's try another one. HNO3. Again, I ask myself, oxygen? Yes. So I have to look at the ending. So I'm going to take a look at this ion right away. This ion, anion right here, is the nitrate ion. Nitrate. So it ends in ATE. Ends in ATE, which means this will be blankic acid. So my blank, again, it helps if you spell it right. That was the nitrate ion. Again, getting rid of the ATE. So I get nitric acid. Kind of the complement to this, HNO2. Again, I go through, I ask myself, oh, yeah, there's oxygen in there, yes. So again, I have to look at this anion here. This tells me, since it's the nitrite ion, ite, tells me that it's blank us acid. Again, I drop the ITE, and what I get is nitrous acid. Let's do one with one of the exceptions. Let's say we had something like H2SO4. Again, oxygen, yes. We're going to look at this anion here. This guy is the sulfate ion. ATE, that ATE tells us that it's going to be blankic acid. Now, I can't just go with SULF because this is an exception. Because this is a sulfur-containing acid, this becomes sulfuric. We keep the full name with those exceptions that I talked about. Acid. If I had something like this, H3PO3. Again, oxygen. Yes. Means I need to look at this ion here. This is the phosphite ion. That ITE ending. That ITE ending tells me this is blank us acid. But again, because this is an exception, phosphorus-containing acids, we're going to keep phosphor as our root, and then OUS is the ending, acid.